All right, the last section in chapter 2 deals with transformations. What are transformations? The movie's Transformers. What do the Autobots do? They change. They transform from one thing to another. That's what this is. We start off with the basic function, and then we change it to another position on the graph, or expand it, shrink it, do whatever we need to with it. Ooh, before we do these, I got to go through the library of functions first. All right. Then today we'll do this set next week. So today, what we're going to do today is talk about the library of functions. Transformations won't mean anything unless you know what you're looking at. The library of functions. In high school, they call it the parent functions, which is ridiculous. I think. So let's look at the first one. We're going to have a whole bunch of them. So the first off is if we have a constant number. If we have a constant, some number, what does that graph look like? It's a horizontal line crossing the y-axis at whatever k is. What's the domain? And what's the range? What's the domain? Yeah, it's all real numbers. And the range is simply k, whatever the constant number is. Next, we have y equals x. That's a diagonal line. The domain, all real numbers. And the range is all real numbers from negative infinity to positive infinity. Now we're going to start building up our equations. X squared. This is called a quadratic equation. This one up here is called linear. Quadratic equations look like that. The domain are all real numbers. And the range is simply 0 to infinity. The next one is called a cubic function. The cubic function looks like this. And we can see the ends going forever. So it's all real numbers, the domain and the range. Quadratic are even functions. Cubics are odd functions. This is called a square root function because there's an invisible 2 right there. The root is that number there. Because we know the smallest number that can go inside there, it can never be negative, is 0. So it starts off at 0 and it grows slowly. So it looks like that. This is called a cube root. And that one looks like this. Domain is negative infinity to positive infinity. So is the range. Oop, we forgot the square roots. What is the domain of a square root? Starts at 0 and it goes to infinity. And the range starts at 0 and goes to infinity. Right. Now let's look at the rational functions. What this function looks like is because you can't have 0 in the bottom. When x gets bigger, the function gets smaller. That's on the positive side. On the negative side, it just does the opposite. That's the graph of the rational function. The domain is from negative infinity to 0, and then from 0 to positive infinity. But we can't use 0. That's why it's a parenthesis. Same with the range. Negative infinity to 0, union 0 to positive infinity. What if it's squared on the bottom? A square rational. If it's squared, it can never be negative. So this thing looks like the Atari symbol. The domain goes from negative infinity to 0, and then from 0 to positive infinity. And the range is strictly greater than 0. Cannot equal 0. And we have a couple more. How about the absolute value function? The absolute value tells us it can never be zero. All right, never be negative. What the graph looks like is when x is 1, y is 1, when x is 2, y is 2. Same thing with the negative numbers. The answer cannot be negative, though. So the domain is negative infinity to positive infinity. And you can see from the range, the lowest it can be is 0, and it goes up from there. We talked about one the other day, the greatest integer function. It starts off at, remember, this one just truncates, it cuts off any decimals. So it rounds down to the number on the left. The domain are all real numbers. And the range are the integers. Which other ones am I missing? Oh, this. This is called an exponential function. It looks like this. And it always crosses through 1. The domain is all real numbers. And the range is always greater than 0. The last one's called a logarithm. Log base a of x. It crosses the x-axis at 1. The domain is strictly greater than 0. And the range is from negative infinity to positive infinity. That should have been all 12 of them. There may be 2 more, but at the top of my head, I can't think of them. But these are the ones that we mostly deal with. So, as we'll stop there because it's almost 11 o'clock. The transformations we're going to look at next week are horizontal transformations, moving left to right. vertical, moving up and down, or stretching them, or shrinking them. Those are the four transformations possible. But it helps if you know these graphs to begin with. Because what we're going to look at next is I'm going to give you something that looks like this. I'm going to ask you to graph it without using a calculator, which we don't need a calculator because it all bases down to one of our library of functions. It all builds from there. So which one of these functions do you think matches with this one? Square ratio, yeah. Because we look at the first off, we look at 1 over x squared. So we know the graph basically has that shape. Then we look inside here. Whatever's inside the parentheses where the x is, that's your horizontal shift. And remember when we did circles? It's always the opposite inside there. So what this thing says, it shifts over to -3. The graph shifts over 3 spaces. And this is a constant. That's my vertical shift. It says from there, go down 2, 3, go down 5 spaces. So there's my new origin. So my graph looks the same. So when we're doing these transformations, all we're going to do is shift the origin. First off, horizontally, we shifted it from here to here. And then we shift from here down spaces. That's all we're doing. The graph's going to look the same for right now. And then eventually we'll stretch them and shrink them and all sort of stuff. That comes next week. And then we'll finish that up. And then we'll start chapter 3. That's when we start dealing with quadratic equations. Everybody, I will see you all next week. So do your chapter 2 stuff this weekend.